Okay, so last video is video 50, and we started with this numerical example, which of course we couldn't complete in one video, but we finished this now. I didn't make it clear in the last video. We kind of understand the concepts behind what we're doing, but if we're taking a class, usually we're pretty good at just memorizing our way through a mathematical process. But one thing we're doing is we're getting everything with respect to Q. What is the example? In a perfectly competitive market, a firm has a production function that, obviously, it's Cobb-Douglas. Uh, okay, so input prices are W, that's wage equals 20, rent equals 5, W meaning $20 per unit of labor, uh, people, and, capital is tractors or something, but this is conceptual across any possible example. It doesn't actually matter what we're talking about. But wage is 20 per unit of labor with that, whatever that may be. Rent is $5 or 5 units per unit of capital, whatever that may be. For target Q, find L star, K star, and cost. So LK, I know that we have to kind of, have the book comprehensive up until this point, but they want to find L with Q in it. What do we say? L with respect to Q, K with respect to Q, and cost with respect to Q. It's kind of like, what the heck is the end result? We find the L, the K, and the cost, all of that with respect to Q. So if I can remember, I try to keep my talking down to a minimum, but we literally pick up where we left off. Yeah. So we took the derivative and all that. Let's kind of do a few things that we didn't before. So we always have to see the obvious. We just take the two derivatives, the two partials, and we plug them in here. The derivative with respect to labor is the top, the derivative with respect to capital is the bottom, and we're going to set them to just, it is 4, it's 20 divided by 5, because those values are given. Yeah, we have to have those values given. So that's, whoops. Okay, so moving along here, we did all of this. We're just checking our work. You divide those. We got K over L in the last one. So we kind of left off around this area right here. Yeah, so we have that statement, and then therefore we have this statement right here. And of course, this is what we did last time. If we plug in for K and we do the math, this is all the math here. We get Q equals 50L. We divide both sides, and this is more where we left off right here. Yeah, so this is exactly what we're looking for. We're looking for the labor as a function of Q. We don't write it this way, but it's basically like labor as a function of Q equals Q over 50. So we're trying to find the labor, the capital, and finally the cost, all as a function of Q. So it's all just algebra. The derivatives in this book are freakishly easy, and it's just algebra. So we found that. From before, we have K equals 4L, which is going to be 4Q over 50. Who cares about algebra? 4 over 50 is 2 over 25. We get 2Q over 25, and thus we have that. What the heck? Okay, so we got it correct. They just didn't reduce. But am I correct there? They have 2Q over 25. Yeah, I don't know why they didn't reduce. Of course, we're not moving on. They probably reduce right next page. But the correct answer for K star is 2Q over 25. Okay, good. So we're done. And then the final thing is make the cost function. The cost function never changes. It's just basically memorize all the stuff that came previously. Yeah. And it's blah, blah, blah. That's cost. Construct the cost function, which we did in the previous video. Is cost as a function of WRQ equals WL as a function of WRQ. We don't have to write all this stuff, but this is how it's interpreted. Plus R, K is a function of W comma RQ. That's how it always is, but we just write it like this. The C, the L, and the K are all functions of WRQ, which is what we're using. But it's blah, blah, blah. All of it is right there. We can do it, but we got C. We know that labor is 20. The L that we just got, I just end up writing exactly what they have. Plus R is 5. I guess it's better to write it as 4Q over 50. That way we have the common denominator. Yep, and if we simplify that, this is going to be the answer. So cost as a function of only quantity. What have we found? What we have found is that the W has to be 20. It has to be. We could find other values for a different problem. The R has to be 5, yeah. But we can choose our value of Q. So 4Q over 5. In the end, what we have found in this example is the cost as a function of Q, the labor as a function of Q, and the wage, what the heck? Nope, capital. And the capital as a function of Q. We found all of them as a function of Q such that you can change Q. And you have your minimized cost and the labor and capital that you need to do it, all depending on what Q you want. That's what we found. So that's the final one. The cost is a function of Q. So they do this where they give a linear example. Yeah, so we do have a linear example. And finally, we have to watch out because it's just lingo. There is a certain there is a certain concept behind the lingo, but we kind of lose it just after a day. But we just don't want to say it wrong. But the linear example, we know what the linear example is. Yeah, the linear example is going to be that right there. So we have a linear example, and that is going to be perfect substitutes. We have to be careful. The linear example is perfect substitutes, whereas the L-shaped is perfect complements. So that's the part where I was saying. But we have two examples that I think we're going to skip just so we can kind of move on to something new. We want to kind of have them recorded here. So we'll kind of flip through and just kind of cover that. But it's the same here. So if we have that, remember with the linear, yeah, perfect substitutes with the linear, we have to see if the derivative if the slope for the isoquant is greater or less than the slope for the isocost. Yeah, just remember that one very, very obvious thing. Isoquant, that's Q. We can't call it Q. I want to say isoquant. Iso Q. I just don't feel like writing the whole thing. Yeah, isocost, right? So the slope for one is less than, greater than, or equal to the slope of the other. That's the whole point for this one with condition 2. So we still take the derivatives and we get those, and we do the thing divided by thing. And what is the derivative there? That is the slope. It's the absolute value of the slope, because even though that's, anyways, who cares? It's always going to be the slope. And then we do the W over R, and we can go back in the last 1 or 2 videos to see the slope, to see the 3 graphs. We just want to memorize the 3 graphs or the 3 conditions from the previous one. And if the left side, if the MPL over MPK is greater than the W over R, then we choose that bottom little thing such that K equals 0. And then we have to find L. All of this is way easier than the Cobb-Douglas one. Yeah, so this whole thing is the solution if we want to go through that. Okay, so they solved that. Example 3 is the distant third. That's going to be the perfect complements, the L-shaped. So this one is actually a little bit hard. We have to understand the proportions. Yeah, so if you want to do this one, it's all about this here. The firm needs to use exactly 3 units of labor, L, and 2 units of capital K. So we have these. That's always going to be the same. Just divide them. Yeah, but we're going to have that kink. It's the L-shaped. So we're going to have the kink there. Condition 2 is must be at the kink of an isoquant. So when they do this,